Hello students, welcome to AdiChemistry's online classes. Today I will simplify the concept of oxidation states, also known as oxidation numbers, specifically designed for those new to chemistry. By the end, you will grasp this fundamental concept with ease and confidence, ready to apply it anytime, anywhere. I am Aditya Vardhan from adichemistry.com, Warangal. Let us begin. The oxidation number or the oxidation state is defined as the hypothetical formal charge said to be acquired by an atom while making bonds with other atoms. Let us illustrate this concept with a few examples. The first example is sodium chloride. In the formation of sodium chloride, the sodium atom loses one electron to form Na plus ion, while chlorine gains this electron to form a Cl minus ion. Since the charge on sodium becomes +1, its oxidation number in NaCl is also taken as +1, whereas the charge on Cl becomes -1, so its oxidation number in NaCl is taken as -1. One should also keep in mind that before the bond formation, both sodium and chlorine exist in their elemental states, and at this stage they don't have any charge. Therefore, their oxidation numbers are both 0. In this example, we will see the oxidation numbers of calcium and oxygen in calcium oxide. In the formation of calcium oxide, the calcium atom loses 2 electrons by giving calcium 2 plus ion, while oxygen takes these 2 electrons by giving O2 minus ion, which is otherwise known as oxide ion. Now in calcium oxide, there is 2 plus charge on calcium while 2 minus charge on oxygen. Therefore, the oxidation number of calcium is +2, while for oxygen it is -2. Let us examine the formation of a covalent bond between two hydrogen atoms and determine the oxidation states in the dihydrogen molecule. Each hydrogen atom contributes 1 electron, forming a shared electron pair that is equally distributed between them. Consequently, neither hydrogen atom gains nor loses electrons in the process. As there is no change in the electron distribution, the charge on both hydrogen atoms remains 0. Therefore, the oxidation numbers of both hydrogen atoms in the H2 molecule are 0. Now let us examine the formation of HCl molecule. In the formation of a covalent bond between hydrogen and chlorine atoms, the electron pair is indeed unequally shared due to the difference in electronegativity between hydrogen and chlorine atoms. Chlorine, being more electronegative, attracts the shared electron pair closer to itself, resulting in a partial negative charge on the chlorine atom and a partial positive charge on the hydrogen atom. As a result, we assign the oxidation number of +1 to the hydrogen atom and -1 to the chlorine atom in the HCl molecule. Indeed, it is crucial to remember that when determining oxidation numbers, we need to consider two main factors: the electronegativity of the bonded atoms and the number of electrons participating in the bond formation. Electronegativity influences how electrons are shared or transferred in a bond, while the number of electrons involved in bond formation decides the magnitude of charge. By considering both these factors, we can accurately assign oxidation numbers to atoms in a molecule or an ion. Let us go through the rules of oxidation numbers, which help us assign oxidation states to atoms in molecules or ions. Rule number 1. The oxidation state of atoms in their elemental state is always 0. Here are some examples of atoms in their free elemental state. For instance, the oxidation state of hydrogen in dihydrogen is 0. Similarly, the oxidation number of oxygen in dioxygen is also 0. In the case of phosphorus, in the P4 molecule, the oxidation number of phosphorus is also 0. This pattern applies consistently across other elements which are in their elemental forms. This is rule number 2. Being the most electronegative element, the oxidation number of fluorine is always -1 in its compounds like HF, NAF, CaF2, BF3, etc. However, it is essential to remember that in its elemental state, that is difluorine F2, the oxidation number of fluorine is indeed 0. This is rule number 3. In compounds, the oxidation state of alkali metals such as sodium and potassium, which belong to group 1 of the periodic table, is always +1. Similarly, in compounds, the oxidation state of alkaline earth metals such as magnesium and calcium, which belong to group 2 of the periodic table, is always +2. And these are few examples. This is rule number 4. The oxidation state of oxygen is -2 in most of its compounds. These are a few examples of compounds formed by oxygen. In all these cases, the oxidation state of oxygen is -2. However, there are a few exceptions to this rule. The oxygen atom shows positive oxidation state when combined with fluorine, because fluorine is more electronegative than oxygen. For example, in O2F2, the oxidation number of oxygen is +1, while in OF2, it shows +2 oxidation state. Also in peroxides, the oxygen atom shows -1 oxidation state. The examples are H2O2 hydrogen peroxide, Na2O2 sodium peroxide. In superoxides like NaO2, the oxygen atom shows -1/2 oxidation state. These are few exceptions. This is rule number 5. The oxidation state of hydrogen is +1 in most of its compounds. These are a few examples in which hydrogen is combining with the more electronegative elements and is showing +1 oxidation state. However, when hydrogen combines with the less electronegative atoms, it shows -1 oxidation state. For example, lithium hydride, cesium hydride, calcium hydride are the compounds of hydrogen in which hydrogen is combining with the less electronegative or otherwise more electropositive metal atoms like lithium, cesium, calcium, etc. So in these hydride compounds, hydrogen shows -1 oxidation state. Now the rule number 6 that deals with the oxidation state of halogens other than fluorine. The halogens other than fluorine show -1 oxidation state in most of their compounds. These are a few examples. The halogens show -1 oxidation state in these compounds since they are making bonds with less electronegative elements. However, they show positive oxidation states also when they combine with atoms with relatively higher electronegativity. For example, in ClO2, the oxidation state of chlorine is +4 since it is less electronegative than oxygen atom. In IF7, the oxidation state of iodine is +7 because it is less electronegative than fluorine atom. This is rule number 7. The oxidation state of monoatomic ion is always equal to the charge on it. For example, the oxidation state of iron in Fe2 plus ion is +2. In cobalt 3 plus, the oxidation number of cobalt is +3. In case of N3 minus nitride ion, the oxidation number is -3. And in sulfide ion, the oxidation number of sulfur is -2. Finally, the sum of oxidation numbers of all the atoms in a compound or a polyatomic ion is equal to the charge on that compound or the polyatomic ion. In case of neutral molecular compound, the sum of oxidation numbers of all the atoms in it is equal to 0. In case of a polyatomic ion, the sum of oxidation numbers of all the atoms in it is equal to the charge on that ion. It may be positive or negative. Let us try to understand this. In case of H2O, there are 2 hydrogens and 1 oxygen atom, and the sum of oxidation numbers on these atoms is equal to 0 since H2O is a neutral molecule. Whereas in case of OH minus ion, the sum of oxidation numbers of oxygen and hydrogen is equal to -1 since the charge on OH minus ion is -1. Now let us apply above rules to find the oxidation numbers. The first example is CH4. Our task is to find the oxidation number of carbon atom in methane. The sum of oxidation numbers of carbon and hydrogens is equal to 0 since methane is a neutral molecule. And we know that the oxidation number of hydrogen is +1 because carbon is more electronegative than it. Now solving the equation will give -4 as oxidation state of carbon in methane. In this example, Let us find the oxidation number of sulfur atom in sulfur dioxide molecule. The sum of oxidation numbers of sulfur and two oxygen atoms is equal to 0 since sulfur dioxide is a neutral molecule. We know the oxidation number of oxygen atom is -2. Now solving the equation will give +4 as oxidation state of sulfur in sulfur dioxide. In this example, let us find the oxidation number of carbon in carbonate ion. The sum of oxidation numbers of all the atoms is equal to -2 since the charge on carbonate ion is -2. Now solving for carbon will give +4 as the oxidation state of carbon atom in carbonate ion. That's all for now. Visit adichemistry.com for more information on this topic or search for AdiChemistry oxidation number by using any search engine. Don't forget to like, share and subscribe. You can also find links to worksheets and other study material in the description section. If you find it difficult to reach them, don't hesitate to ask me in the comments section or drop an email to adichemjee@gmail.com.